Welcome to this brief tutorial on the RMS glass shader in Renderman for Maya. So in this tutorial I've actually already set up a few objects. Now they're quite simple objects. And what I've got here is a pipe and a cylinder, which are the two main objects which I want to be looking at. And for these I've inserted some edge loops close to the ends so that when I actually subdivide them we'll be getting something which is more like this, more like this. Okay, so let's just unsubdivide. So using our subdiv scheme we'll be getting that kind of effect. Now I've also brought in a torus knot from 3D Studio Max, and I have one of my stock standard spheres here. I will be applying the same glass material to all of these to show the way in which the actual topology and size and shape of objects will affect the physical properties, or the physically plausible properties of glass. So let's just start off by making sure that all of these objects actually have a subdiv scheme, which I really want to have on them. So add a subdiv to this, and in this case I'm going to add a subdiv and just check. In this case I probably want to set it to loop. The difference between these is loop is made primarily of triangles, so this mesh is made primarily of triangles and will probably subdivide better like that. I'm not actually altogether sure, but I'm just guessing on that. Let's hope it does. Attributes renderman and subdiv scheme standard should be okay, and attributes renderman subdiv scheme. Okay, I'm going to start off by putting just a matte material on all of these. Just throw that material onto them, and let's just try rendering. Render. It started up. Very quick render. Set this to always on top, and let's just organize my view a little bit better so I get to see things a little bit closer, a little bit nicer. Re-render. Okay, so that's not looking bad at all. Okay, so what I want to do now is I want to apply the same glass material to all these objects. So apply glass material to all of them. So glass material is one of the standard materials which we have up here. This is glass, this is the general purpose material, and this is matte. So glass material I can apply from here, and I'll just hit render. And everything appears to be black. Now the reason for this is the glass material really requires ray tracing, or a render which supports ray tracing, I should say, in order for it to be seen correctly. So in our rendered globals I need to actually turn on the feature of ray tracing, and let's just try re-rendering this. So we're getting something, but it's looking a little bit noisy at the moment and a little bit dark. So one of the things I will usually do is put in an environment light, and put in my standard image, which is my favorite Fin 4. If you're getting tired of Fin 4, I may well change it to something else in the near future. Got lots of other free HDRs. Thank you very much to all the people who make these. You will get credit. So Fin 4 is down here. EXR, I do like EXR. And do a re-render. Okay, so you can see we're getting some results. Still pretty noisy. Something very strange happening with our pipe, whereas these objects here, not looking too bad. Certainly the sphere and the cylinder are looking the best of all of them. Now let's just try and reduce our noise slightly by increasing some of our samples here. Increase my samples to 128. Re-render, just to get things looking a bit neater for ourselves before we actually start tweaking the material settings themselves. Okay, looking better. And again, with our quality settings in Renderman, I can set my shading rate to 1. Now this may take a while. If it takes a while, I'll actually pause the render and come back to it. So I'll re-render this. Doesn't seem to be doing too badly. And we're getting a reasonably clear image now. We still have some noise. That's actually, some of that is to do with the internal structure of the glass shading material. Okay, now one of the things which is obviously wrong with this is in our pipe here, it's not shading correctly. We're getting this black looking color here, and we're getting quite a lot of blackness in our torus knot. Now the reason for this is to do with our material. So let's dig into our material and let's have a look. Okay, so we have a glass color. It's the same on all of them. What is happening with this, in actual fact, is not the material's fault. It's to do with the features here and the ray tracing. Ray tracing, in actual fact, has to calculate its way through each of these objects. So it's calculating as it goes through the object, and through the object, and through the object. Now, in this object here, we have, let me just pull this down here slightly. We're going to go through the outside, the inner side, the next, and the next. So it's going through 4 surfaces. But we only have our specular rays here. Specular depth is set to 2. If I bump it up to 5 and I re-render, we should get a far superior result. And yes, indeed we are. In general, when we're working with transparent materials, it's advisable to actually calculate the number of reflection and refractions which we are likely to see, and add at least 1 or 2 on top of that. Now 5 is going to give us a reasonably good result here, but at least add 1 onto that. So you can see we're getting something which is pretty close to a realistic glass material. And our torus knot is cleaned up substantially here as well. Okay, so out of the box, the RMS glass material is looking pretty nice. Now, what are some of the settings which we have here? Let's have a look. The first which we have here is the glass color. Now, glass color works together with the compute absorption. If we just hover over here, we should get some, yes indeed, we get a little tooltip. Compute light absorption based on Beer's law. Glass color is used as the absorption value. Lighter colors absorb less light. You need a very pale color for the effect you want to. Use Beer's scale to adjust the per unit behavior. Okay, so what this is saying is that we can actually tint our glass color, and let's go for something very, very pale indeed. Let's say we're going to go for green bottles, and we're going to bump it up to about 0.062 in our saturation. Okay, and I'm going to re-render this. Now, Beer's law is a physical law which deals with the absorption of light in materials. So one of the things which is a prime result of that is the thicker the material, the more light which is absorbed, and in this case the more which we'll be getting the color visible in our glass material. So this is based on a physical law. And again, we're producing really nice results here, which is what you would in actual fact expect. If you have a piece of glass which is very thick, you'd expect the color in that to actually be richer than a piece of glass which is, for instance, like our pipe over here, which is quite thin. Okay. Now, if I was to turn off compute absorption when this render completes, we'll actually see we get a slight tint to all of the glass. This will barely change at all. And I'll actually bring up the, okay, just bringing up my catalog here. So I'll re-render this. You'll see that the color here barely changes at all, whereas for the large cylinder here it changes dramatically. So let's re-render. Apologies, rendering does take a little bit of time. So you can see in this case, the solid cylinder is giving almost the same results as the pipe, or the thin-walled glass object, which is pretty obviously not physically realistic. Okay, let's just let this run through. Almost finished. And there we go, that's render finished. Now, let's have a look. Let's just put on our absorption again, because I much prefer having that there. The specular properties are one of the highest priorities for a glass material. Now, the specular roughness is how shiny the glass is, basically. So a very low level like 0.001 will be giving us nice, crisp reflections and refractions. If I was to move this up slightly higher, let's just even 0.05, and let's try re-render it. Again, I'll just pause while this renders. It's beginning here. You see a slightly frostier look to the glass. Okay, and this render is nearly complete, and you'll see that we're getting a much frostier look, but also slightly noisier. And that noisiness is something which we would like to actually get rid of. So that's the clear glass, and that's with the roughness turned up to just 0.05. So in order to work with the roughness, if we just hover over here again, we should get a roughness of the primary specular lobe. Smaller values are sharper. It will cause reflections, refractions to get incoherent the more that we actually increase it. So let me just go down to improve on this. What I'm going to do is I'm actually going to bump up my direct light samples 32, my indirect light samples to 64, and I'm going to re-render. And we get this part of the scene very cheaply, and it just starts to render here, and I will put a pause on. And I think I may have actually set those light samples, these light samples over here, to be a little bit too high, because it did actually take ages for that render, so apologies for that. But the result is worth it. Blurry reflections and blurry refractions will always take more time. They're one of the things which you just don't get for free. So this was the sharp reflections with our setting here in the roughness at 0.0001. This was the 0.05, but with the samples set at low, so that was I think that was 2 and 8 there, and this is the high settings here. So the difference between this and this, really nice blurry reflections and really nice feeling of basically manufactured glass, which you do quite often see in light fittings. Very much like that kind of greenish color. Okay, so what we've looked at so far is we've looked at the glass color, computing absorption according to Beer's law. Now I can also fiddle with the unit length here, which will change the amount of absorption. Before I continue, I'm actually going to drop this number down here, and I'm going to drop my samples back down again, so that future renders don't take quite so long. If I was to increase this unit absorption length here to say 5, and I'll just do a quick rerender to show you that, just so we're aware of what happens. And I will pause for you here again. Okay, so we're getting kind of Christmas tree lights, that kind of greenish color here, because the absorption unit has actually been changed. Even though it's incredibly here, the effects which we actually see here are quite dramatic. Very nice rich green color. So the next thing I want to have a look at here is our specular gain. Now in order to do this, I'm going to actually put a light in the scene because we don't get an awful lot of specular from an environment light. So once this is finished, and it nearly is now. Okay, I'm going to put this back down to 1, and I'm going to put in a standard RenderMan area light. Okay, and I like that. So put in my unit to 1, and I'm going to put in an area light. Let's just bookmark my view here. So camera, bookmarks, edit bookmarks, and new bookmark, call it marks mark, just so we have it there. Just make sure view, yep, it's there. So I'm going to put in an area light. Standard area light comes in the middle of our scene. Let's move it up. Let's vaguely rotate it around to where we need it to be, somewhere around like that, pointing down somewhat. I'm going to change the intensity to about 5. This is kind of guesswork. It will require some fixing afterwards. And I'm going to scale it up. Let me just move this over here. Sorry about this. So my scale, I'm going to change the scale, scale. Okay. Let's just do it like that. Okay, I'm going to look through this just to make sure where I'm at. Make sure we're pointing at everything and put it far enough back that it will be illuminating everything. Okay, that's not too bad. Let's go back to our bookmark. Oh, in fact, let's just drop in here. Okay, that'll do me. So that light is now there. Let's just open up our outliner. I'm probably going to have to bump that up slightly. Let me hide. I'm going to hide my environment light. So I'm just going to do a quick render. Rendering over here to see what kind of effect we get. Yes, that light is very, very low level. We're getting quite a bit in the middle here. So what I might do is, in fact, just scale it up slightly in size. A couple of things I want to tweak with it, with the area light. And my attribute editor for this, the shadows I would like to have set to being aggressive, and trace shadows is on. For my glass material, I want to have my shadows to being view dependent. And I'll re-render this. Okay. So we should now get proper shadows coming from these lights, or from the light through the glass objects. And in actual fact, the color of the object is coming through. Okay, which is really, really a nice effect. Okay, pretty cool. Looking good. I think I'm actually going to leave things here for the moment and come back with a second part of this tutorial possibly tomorrow. Things are getting on a little bit, so there's a few more things I want to cover with the materials. So thanks very much for listening to me so far, and hopefully you've managed to make your way through this whole tutorial. I will come back with some more information on the glass material. As you can see, it's pretty simple to set up and very, very powerful. You can produce some absolutely lovely results with it. So thanks very much for the moment, and I'll come back with more.